Welcome back everyone. So yesterday we discussed Prim's algorithm, where we learned to find the minimum spanning tree. If you haven't watched that video yet, make sure to check it out first. So today we are going to another important graph algorithm, that is Warshall's algorithm. So this helps us to find whether a path exists or not. So the main idea is to check whether there is a path existence, and it is used to find reachability between the nodes, between all the pairs of nodes, and this works on transitive closure. That is, transitive property means that if A is connected to B and B is connected to C, then A is connected to C. This is what transitive means. And transitive closure here means if A is connected to B and B is connected to C, then there is an edge between A and C. So in input we will be giving it as A is connected to B only and not C. So there will be no edge between A and C. But in the output we have to get it as there exists an edge between A to C. So we'll look into an example and then move to the code. Here again we'll be giving input as adjacency matrix, the same thing we have given it to the Prim's algorithm yesterday. So this is the graph given. If we have to write the input adjacency matrix to this, we'll be writing it as a 4 cross 4 matrix where A is not connected to A, so it will be 0. A to B is connected, A to C there is no edge, and A to D also there is no direct edge. So this is the input. So no direct edge means 0. So from B there is only one edge towards D and all others are 0. And from C there is no edge at all. So since this is a directed graph, we can only consider towards the arrow. So for Prim's algorithm we saw it as undirected graph only. So here it will be only directed graph. So from D towards A and C, and the other two will be 0. So now we have to check that in the output we get another array again. So from A to A, is there any edge? So from A we can go to B, from B to D, and D to A. So there exists an edge between A to A. So it will be 1. So from A, we will take from here and towards the top element. So from A to B there is a direct edge. From A to C also, A to B, B to D, and D to C. So there exists an edge, and of course A to D also exists an edge, that is A to B and A to D. So from B there exists an edge towards A, B to D and D to A. From B to B also, because B, D, A is forming a triangle and there is an edge. From B to C also, B to D and D to C, and B to D direct edge. From C there is no arrow mark towards another edge, so it will be 0 because no edge starts from C. And from D again all can be reached because D to A and D to B, then D to C, again D to D, this triangle. So all the nodes can be reached from D. So this is the output we want. So let us look into the code for this. So let's start with the code here. As I have said in the previous video, I have created a package DAA lab and I will be doing it inside that. So for any user input, we will import the inbuilt class scanner class, and let us start with the main class now. So whatever the class name we give here should be same as the file name. So I have taken it as Warshall class and I have given the same. And these are the global variables, that is, we'll be defining the max value as 20 and an array, 2D array called A, and an integer n to store the number of nodes. So here all static means that the value cannot be changed later. And we will start with the main function here. So inside the main function, we have to assign the integer array size, that is the whatever the 2D array we declared there, will be initializing it that it can have up to max value. So here max refers to 20, and we will use three user defined functions, that is read matrix, Warshall, and print matrix. So that we will be writing it now. So here static void read matrix. So void means the return type of this function is nothing. So it is void. To read any matrix, we want a scanner. So we'll be giving it as scanner SC. So name of the object is SC, and constructor we use system.in. So system.out.println will ask the user to enter the n value, that is the number of nodes the graph has, and we'll be taking the integer input. Then we will ask the user to give the adjacency matrix. To take any array input, we use for loop. Since it is a 2D array, we need two for loops that runs from I1 to n and j1 to n. So we need to take the input to the a of I of j array. So we will close the scanner here and we'll go to the next function, that is static void versions. So here we define these two and the error is not there, and we have to define even this one. In the Warshall class, we'll be writing the logic, that is what I said, the transitive closure. So for the transitive closure, I used ABC there. So we'll be using here I, J, and K. So there will be three for loops. So int k is equal to 1, k less than or equal to n, k plus plus, and the second for loop runs from 1 to I less than n, and the third for loop runs from j1 to j less than n. And we'll be writing the transitive condition, that is, if there exists an edge between I and j, or if there exists a edge between I and K, and if there exists a edge between K and J. So there, if there exists an edge means if it is equal to 1, so double equals to 1, then we'll make it as 1. So we'll be updating the value of A of I of j to 1 whenever this transitive condition holds good. So we'll go to the next function, that is static void print matrix. We need to print the matrix now. So we'll be using system.out.println. This is transitive closure. So again, for printing we need two for loops that runs from I1 to I less than n and I plus plus, and for int j1 to j less than or equal to n j plus plus, we will be printing system.out.println A of I of j, because we are updating I and j value, plus some space between each element, and after each row we need to go to the next row. So second row will be printed in the second line using other system.out.println. So this line makes it go to the next line after the first for loop. So this is inside the ith for loop. So this is the code, and we'll be running it and give the input same as what we discussed in n to n. So the number of nodes was 4 and the matrix was 0, 0, 0. So this was our input matrix, and the output matrix is all ones except the third row. That is, from C there was no starting edge. So this is the output we get. So try it out for the other examples. I'll be posting one example at the end of the video. So try for that and comment down the matrix. So thank you for watching, and please subscribe for more such videos.